Hi, in this video I explain the basic concepts for interest. Okay, so first definition, an accumulation function. Accumulation function is denoted by the A of t is the value of an asset at time t. For standardization purpose that we define A of 0 is equal to 1. So we use this symbol. So this means that is defined by. So this is standardized. So A of 0 is equal to 1, and this becomes different value when the time passes. So basically, if we think about the t as on the horizontal axis, the time as horizontal axis, and the accumulation function on the vertical axis, then the graph is basically like this, maybe. So the amount always increase over time because this is fixed income products. I mean, if interest rate is positive. So the A of t is monotone increasing function, and in general, this shape. So this is y is equal to A of t. Or in simple interest case, so this just becomes the straight line. So this may be another example of AT. So given the time point 1, 2, 3, that you can see what's the value. So if the first year the interest rate is 10%, this value may be 1.1 or so on. So this is the definition of accumulation function. Okay, so next, the definition of amount function. So amount function, we often use the capital A of t. So amount function capital A of t is the same as accumulation function A of t, but the A of 0, the capital A of 0 does not have to be 1. So that is for some k. So A of 0, A of t is equal to k times the A of 0 for some function, A of t, sorry, for some function, the lowercase a of t. So capital A of t is the amount you have. For example, if you have $100 at time 0 and the interest rate is 10%, 100 becomes 110. So capital A of 0 is 100. Capital A of 1 is 110. So AT is the amount you have. So just the difference is K. Yes. And some terminologies. So in some questions, the start and end points are clear. For example, if we think about the 30-year mortgage, the start point is today and the end point is the 30 years from now. So in this case, we say the capital A of 0 as present value. And capital A of t. Okay, so start time is 0, end time is capital T. Then A of 0 is called the present value. And capital A of t, capital T, is called accumulated value. So often we have PV or AV in actuarial mathematics. Okay, so next, the definition of effective rate of interest. So effective rate of interest in the this year is defined by A of t minus A of t minus 1 over A of t minus 1. So this is the usual definition. So at time t minus 1, the amount is A of t minus 1. That becomes A of t. For example, the 100 becomes 110. Then we have 10% increase, but that is 110 minus 100 over 100. So this is the definition of effective rate of interest in the tth year. And we use the notation I sub t. A little vague, so I sub t. Okay, so if we use the amount function, capital A, then you can do the same thing. The capital A of t minus capital A of t minus 1 over the capital A of t minus 1. So anyway, everything is k times larger, but the proportion, the ratio does not change. So for example, if the I sub t is equal to 0.08, that means the amount increases the 8% in tth year. So 80 increases 8% in tth year. Yeah, so yes. And the example, for example, suppose that the accumulation function, the A of t is equal to 1.1 to the power t, then what is I1 and what is I2? Then I1 is the interest earned in the first year. So that means the A of the 1 minus A of 0 over A of 0. So that means the 1.1 to the 1's power and the 0, 0. So that means the 1.1 minus 1 over 1. So this is 0.1, so 10%. And since this is exponential function, you can imagine that this does not change for the second year or third year and so on. So A of 2 minus A of 1 over A of 1. So that is equal to 1.1 to square minus 1.1 to the first power. But anyway, if you just the cancel 1.1 on the denominator and the numerator, so that becomes 0.1 again. So this is 10%. So for this exponential function, the IT is constant. So if IT is constant, so we only think about the case that t is integer, that we write I is equal to I sub t. Yeah. Okay, so a little more complicated example, maybe the other way around. So suppose I1, the interest rate for the first year is 1%, 0.01. Second year, I sub 2 is 2%. I sub 3 is 3%. So this is typical case. So the central bank changes interest rate, usually just usually the 0.25% each time. So if we have the 4 interest rate hike in a year, the 1% becomes 2% in the next year. Then after that, 1 year later, 1 more year later, it becomes 3%. This is often the case. Then what's the accumulation function at time 3? Then you can see that the A3 is equal to the A2 times, maybe mathematically speaking, the A of 3 over A of 2. right? But this is equal to, you know, a of 2 times the 1 plus the a of 3 minus a of 2 over a of 2. Okay. So this is basically why we define I of 3 as this quantity. So this quantity is I sub 3. So this is the 1 plus I3. So in the same way, we can say this is A1 times 1 plus I2 times 1 plus I3. And this is A naught. A naught is actually 1. 1 plus I1 times 1 plus I2 times 1 plus I3. So this means the A of naught is equal to 1, and 1 plus I1 is equal to, sorry, the 1.01 and 1.02 and 1.03. So this is about 1.06. Maybe to be exact, this is 1.0611. So you can get the A of 3 here. So in general, we can say that the A of t for a given integer t is equal to 1 plus a I1, 1 plus I sub 2, up to 1 plus I sub t. Or you can say just the product, maybe t is equal, maybe j is equal to 1 to t, the 1 plus I sub j. Yeah, so this is how the effective rate of interest works. So effective rate of interest is given by this formula, and the other way around. So if the effective rate of interest rate is given, we can calculate the accumulation function.